Okay, today we are going to look at two features of a river. One is called floodplains and the other is called levees. So as you can see, these are both what we call depositional features, and they are found in the middle and the lower course of the river. So to understand how these work, we have to understand first of all this word depositional. Depositional features are features that happen because of deposition. So we need to understand that term, deposition. It was introduced to you a couple of lessons ago, and it is all about when rivers drop material, because all rivers are carrying material. And again, as a recap, we want to think about and remind ourselves how rivers are carrying material. Can you remember? There are four different ways that rivers can carry material. Can you remember what they are? They are all to do with the size of the particles. So the big particles, the big boulders and rocks that are found on the bed of the river that can't be picked up. They're really, I mean, we can't pick them up. Humans can't pick them up. They're so big and heavy. These can only be moved by the river when the river's flowing really fast and there's got lots of water in it, and they roll these along the bed of the river, and we call that traction. The slightly smaller rocks, still quite big often, but slightly smaller ones can be bounced along the riverbed. So they literally bounce along the bed of the river, and we call that saltation. Now, tiny particles of rock, sort of almost grains of sand, and sometimes a little bit bigger than a grain of sand, these can be carried by the water. So they literally sort of float along and they're held in suspension. So that's the next type, suspension. And the final type are things that are so small they can be dissolved within the water. We call that solution. And these are what make the river, or give the river, a really muddy looking brown color. That's when material is being carried in solution. But the river can only carry material if it has the energy to do it. And if it doesn't have the energy, it has to drop the material or deposit the material. And when that happens, sometimes we get features, and two of these features are called floodplains and levees. So if you remember the meanders lesson, you'll remember this because if you remember the inside of the meander, what happens? What happens on the inside of the meander? The inside of the meander is going very slowly, the water is going very slowly, and therefore it lacks energy, and therefore it has to drop its material. And it drops its material in and creates a landform that we call a river's beach. So on the inside of the meander, you get a river beach because of deposition. So that is actually another feature or landform created by deposition, the river beach. But in the lower course and the middle course, what we're going to focus on today are times when there is lots and lots of water in the river, too much water for the river to carry, and therefore it creates a flood. And it is these floods that create these two landforms, the floodplain and the levees. So I'm just going to start by just drawing a fairly typical river channel. So this would be hopefully fairly easy for you to understand. These are the banks, one either side, but I'll just label one. And this is the bed of the river. The riverbed and river banks create the channel. And we have water, of course, flowing in the channel. So all of this is water. So that's the river channel. Actually, what I'll do is I'll try and just make this look a little bit more 3D so it sort of makes sense to you. So the river is flowing. Oops, the river's flowing like that. So let's get that water. So the river's flowing all the way along here. Okay. So hopefully that does make sense. You might have some trees on either side of the river. Here like this. Okay. So and let's say that the river is traveling in this direction. in this river. So here we go. Hopefully that makes sense to you. Now, typically, on most days of the year, that just happens, and the river is like that. But sometimes you get lots and lots and lots and lots and lots and lots of rain. And if you get too much rain, what happens is, and I'm just going to draw another simple version of this. So typically, the water in the river is there, but when it rains and rains and rains and rains and rains, what happens is the water level rises and it rises and rises until you get right to the top of the river banks. Now we call this bank full stage. And if it continues to rain, and of course water can get into the river by through flow through the soil, groundwater flow through the rocks, overland flow or surface runoff over the top, or it might actually even rain just directly into the river. So if it's raining a lot and you get lots and lots of water getting into the river, then you'll get the river spilling over the banks, breaking the banks of the river, it's called, and we get a flood, and it will flood over onto the surrounding land. Now, I'm just going to show you a image so you can sort of see that in real life. So this image here, you can see the bottom image is the river normally, and the top image is the river in flood. So let's say that the water is traveling in this direction. Now, in the top image, where it's in flood, you can see it's in a different season of the year, can't you? Because in the top image, you've got trees with no leaves on it, whereas in the bottom image, you've got trees with leaves on it. So in the top image, you can still see the river, and the river's still flowing. In fact, it's probably flowing even faster than it is in the river at the bottom. But up here, you've got a flood. This is all flooded land. Now, the important thing is about the energy that the flooded water has. The river is still moving. It still has energy. But the flooded water does not move. It is just sitting there. No movement, no energy. What's it going to do to the material that it is carrying? And you can tell it's carrying lots of material. Look at the difference in colour between the two rivers. The river at the top in flood is carrying much more material, and it's carrying material in solution. You can tell that because it's a muddy brown colour. So all of this river flooded water is stationary. It's got no energy. It's going to drop its material. So going back to here, the flooded land will get a layer of material that is going to be dropped by the flooded water. Now, what happens is, year on year, this is dropped every time it floods, and it may flood once a year, twice a year, 3 times a year, but every time it floods, these rivers, all the area around the outside of the river here, will be layered in material that was dropped by floods. And what it creates are what we call floodplains. Flat bits of land on either side of the river that is made up of material that the flood water was carrying, and now it drops it. And of course, what this does is it flattens out the area either side of the river. So it creates a flat piece of land on either side of the river. The other thing about floodplains is, look at the material, very dirty, very muddy, that it drops. It's carrying lots and lots and lots of goodness, nutrients. And so the floodplain areas here, over time, become excellent for farming, because this land is really what we call fertile soil. So it is excellent for farming. So on either side of the river, in the middle course and the lower course, you will often see farmland, crops growing, because it's such a really, really fertile piece of land. Now, the third thing is why is it that we get levees and what are they? So again, back to our basic design of our river channel, back to the fact that we are at bank full stage. It's just about to flood. Now, as it floods over, the river will be carrying lots of different material. Some of it tiny material, some of it slightly bigger material, and some of it even bigger material. Now, as soon as it leaves the river, which material will it drop first? Which will be the hardest for it to carry? Yeah, it's going to drop, first thing it's going to drop is the biggest material. So you get the biggest material dropped here and the smaller material dropped further on. Also, when you get a flood, does it always flood all over the floodplain? Or do you often get floods that it only just gets over the banks of the river? The answer is yes. Quite often you'll get very small floods that don't go very far from the actual banks of the river. And so not only do you get the biggest pieces of material next to the riverbed, next to the riverbanks, you also get more material deposited there. So what you end up with is instead of the very basic river channel that I've been drawing like that, what you actually get is a river channel that looks more like this. Because these bits on either side are built up higher than the surrounding land. So you have the river in there, and then you have the floodplain over here with its lovely fertile land. You have lots of crops growing and farms, and you get the levees. So these are called levees. Now, these are also, as you can probably work out, natural. They're not man-made. They're natural, but they're natural river defences. The bigger the levees, the more water the river has to have before it can actually break free and flood the surrounding land. So there we have floodplains, the flat piece of land either side of the river, and we have levees, which is the raised riverbanks due to flooding. The raised riverbanks due to flooding, which act as natural barriers or natural defences to flooding.